The traditional search traffic model has broken. For 20 years, businesses built their digital infrastructure around ranking for human clicks, but that mechanical link between search position and business value has severed. The baseline click-through rate for the top organic search position has plummeted to 2.6%, and 60% of searches now end without a click. But a new baseline emerges. Traffic referred by AI platforms has surged by 300%. The audience hasn't disappeared, they've migrated. Capturing this migrating audience requires generative engine optimization, or GEO. GEO is the technical discipline of structuring web data specifically for ingestion by large language models, rather than human readers. To win market share in 2026, engineering teams must stop optimizing for human clicks. The core objective is now architecting for machine citations. We are no longer operating on a single, unified search internet. The web has bifurcated into two distinct ecosystems, defined entirely by user intent. For high-stakes transactional purchasing queries, Google maintains a massive 90% share. Users still browse multiple sources to spend money. However, ChatGPT captures 64% of generative intent, like creative tasks. Engagement is also deeper. ChatGPT sessions average 13 minutes, compared to just 6 on Google. These generative engines extract information through RAG pipeline ingestion. RAG, or Retrieval Augmented Generation, is a framework that allows an AI model to pull facts from external databases or live websites to ground its answers before generating text. A single infrastructure is no longer sufficient. Publishers must maintain a front-end delivery system rendering HTML for human readers, and a parallel, highly structured delivery system optimized specifically for RAG ingestion. When the industry realized AI crawlers needed machine-readable data, the immediate reaction was to adopt a new signaling file, llms.txt. It was pitched as a new robots.txt for AI, a simple directory file intended to guide language models to a site's approved content. To test its actual utility, researchers analyzed a massive dataset of 300,000 domains. Out of that entire pool, only 10% of websites had actually implemented the file. This XGBoost feature importance graph isolates the impact of different SEO variables. The presence of an llms.txt file has a statistical impact of exactly 0 on AI visibility or citation rates. Removing it from the machine learning model actually improved overall accuracy. The file fails because major platforms do not actively rely on it in their data pipelines. It is a passive signaling file that introduces noise without altering how a site's data is formatted. Relying on a text file is a placebo. It wastes engineering resources on signaling, ignoring how large language models mechanically compute and consume web data. The core mechanical problem is that standard HTML DOM structures are toxic to AI crawlers. This wall of raw HTML code is dense and highly inefficient, rapidly eating up a language model's context window. A context window is the total amount of text or tokens an AI can hold in its active memory at one time. Simply stripping out the styling and executable scripts reduces the overall token payload by 80%, leaving just the raw text. But raw text isn't enough. AI bots require strict semantic chunking. They parse data best when it is rigidly organized with a single H1, sequential H2s and H3s, and bulleted lists. Structuring a page with this precise hierarchy increases the probability of being cited by an AI engine by 2.8 times. That structured data also requires rigid freshness protocols. Nearly 80% of AI crawlers explicitly prioritize content published or updated within the last 2 years, rapidly discarding older source material. Proper semantic chunking is the required catalyst. It takes a page that already ranks in the traditional top 10 and strips away the computational noise, making it efficient for an AI overview to extract and cite. Allowing consumer scrapers to indiscriminately rip HTML from your server relinquishes control. The alternative is moving content delivery to the edge, maintaining strict publisher-side control. The enterprise-grade engineering solution for this is content negotiation. Content negotiation is an HTTP mechanism where the client and server agree on the specific format of the data being delivered, such as sending plain text instead of complex web code. When an AI crawler requests a page, an edge compute node, like a Cloudflare worker, intercepts it. The node reads the crawler's HTTP header, looking for the request accept text.markdown. Instead of returning the heavy HTML payload, the Edge node dynamically serves a clean, token-optimized Markdown file tailored for the AI's constraints. Critically, this package is injected with YAML front matter, a metadata block containing canonical URL, authorship, and entity definitions. Third-party scraping often strips away attribution context. Injecting this YAML front matter ensures the language model has hard-coded, machine-readable proof of where the information originated, protecting the brand's intellectual property. This creates massive processing efficiency, delivering exact semantic chunks formatted in its native language, reducing total token weight by 80%. Deploying publisher-side Edge infrastructure forces AI engines to consume your data exactly as you dictate. It preserves your brand authority while saving the crawler's processing budget. Allowing third-party scrapers to parse raw HTML completely unsupervised is an immediate business vulnerability. It exposes brands to the compounding risks of AI hallucinations and the silent extraction of proprietary data without compensation or proper sourcing. To establish hard boundaries, the industry is adopting the Content Signal HTTP header as the standard for AI access control. This header dictates exact permissions. By configuring it to AI train equals no, publishers block foundation models from scraping content to train new algorithms. Simultaneously, setting search equals yes allows real-time search crawlers through, ensuring the content answers live user queries. Granular header-level access control changes the power dynamic. It transforms publishers from passive targets of data scraping into active directors of their own intellectual property. Because of these architectural shifts, traditional organic traffic volume must be retired as a primary executive metric. It no longer reflects actual market reach. This dashboard tracks two required executive KPIs for 2026: AI share of voice and citation frequency. Brands must reach a 30% citation frequency on core topics. Crossing this threshold drastically lowers the risk of the model hallucinating incorrect brand information. Dropping below a 30% frequency rate equates to complete invisibility. Maintaining it is the only mathematical assurance of being included in generative engine outputs. Securing that visibility requires strict adherence to three architectural imperatives: precise semantic chunking, edge-deployed Markdown delivery, and rigid header-level access control. The traditional web of clicks and page views is receding. The digital entities that survive and capture market share in 2026 will be those engineered not just to be read by humans, but to be explicitly and efficiently computed by machines.